Hi everyone, welcome back for another lesson on chemical reactions. This time we're going to take a look at reactions that happen in aqueous solutions. So we should know at this point that when ionic compounds are dissolved in water, they dissociate into their ions. So reactions that involve aqueous solutions will typically involve ionic compounds that have been dissolved in water, and sometimes they can involve more than one solution, but typically we work with at least one solution where an ionic compound is in water. So to accurately get a depiction of what's really occurring in this reaction, we can show what's called the complete ionic equation, which shows all of the dissolved ions in the solution since ionic compounds associate and form those free ions. So let's take a look at an example at a double replacement reaction where we start off with two aqueous solutions and we form a precipitate. So we're going to take this balanced equation and write the complete ionic equation. So starting off with our silver nitrate, since this is a soluble ionic compound, it dissolves in water, and those ions are now separate from one another and are free ions in solution. So the silver nitrate, the AgNO3, the real version of what it kind of looks like in this reaction would not be as one entire compound, but rather two separate ions. So we can show this first compound as really a silver ion, and it is aqueous, along with an aqueous nitrate ion, since these two ions are now dissociated in solution. With our second compound, the sodium chloride, we see the same thing occur. Sodium chloride will dissociate into a sodium ion and a chloride ion. So what we've done so far is show that yes, in this equation, we have silver nitrate reacting with sodium chloride. But in reality, since these two solutions have been dissolved in water, those ions are free. So they're not really as AgNO3, but rather as the silver ion and the nitrate ion. Same thing with the sodium chloride. It's not really as sodium chloride. Instead, it's a free sodium ion and chloride ion. Now for our products, we see our first product is the precipitate, silver chloride. Now because this is a precipitate, it is not soluble in water, and so it will not dissociate. So for things that are not soluble in water, we keep as a whole because they do not dissociate, so they would not form those free ions. For our second product, this one is soluble, so we would show the sodium nitrate as free sodium and free nitrate ions. So what we're seeing here is called the complete ionic equation. It is showing all of the actual ions involved in this reaction. So these different compounds are not as entirely formed compounds, but rather than a series of free ions, with the exception of the silver chloride that is not soluble. Now in the complete ionic equation, we're essentially kind of showing everything that's involved here, but not everything is actually participating in the reaction. We have what are called spectator ions. Spectator ions are not directly involved in the reaction. Essentially, these are the ions that are at the start and the end of the reaction. So they really didn't even participate in the reaction. They simply spectated the reaction that took place. The net ionic equation essentially will reduce down the complete ionic equation to show the ions that are directly responsible for the reaction or the ones that are actually involved in the reaction. Essentially, it's just taking the complete ionic equation and removing the spectator ions. Spectator ions did not get involved, and so they are not truly participating in the reaction. So let's take our previous complete ionic equation and further break it down to our net ionic equation. So to do so, we must first identify our spectator ions. So the spectator ions are those ions that are present before and after the reaction. So if we look at the reactant and product side, we can see that we have sodium ions present on both sides, along with nitrate ions. Because these ions are both present before and after the reaction, they did not directly participate, so they are our spectator ions. So whichever ions you see at the very start and end of the reaction will be the spectators. If we then remove those ions from our chemical equation, since they did not participate, we are now left with our net ionic equation. This will be the silver ion with the chloride ion forming our insoluble precipitate silver chloride. So even though originally our reaction had silver nitrate combining with sodium chloride to form sodium nitrate and silver chloride, in reality, the second product never really truly forms because sodium nitrate is soluble, and so those ions were free at the start of the reaction and free at the end of the reaction. The net reaction that actually occurred between those two reactants was the formation of silver chloride through the combination of the silver ion and the chloride ion. So the complete Ionic equation just breaks down your aqueous solutions into those free ions. The spectator ions are then removed, and the remaining ions and substances form your net Ionic equation.